We are told we need milk because it contains calcium, and it contains proteins, and it contains all the things that we need. We also know that there are problems with it, and that there are high concentrations of fat and cholesterol, and so some people are advised to take skim milk rather than milk. So is this true, and how good is milk really? Well, I'm going to use some publications here to show you what the scientific world is saying of this. Of all mammals, human milk has the lowest protein content and the lowest ratio of casein to whey. Now, casein is the protein that you find in milk. And there is a huge production of milk, so if you make evaporated products, then sometimes there is a huge excess of casein in the world. And you can find casein in just about anything, any product, from cookies to baking to power drinks to you name it. You will find casein. And casein is species specific. It's a very specific feeding protein. It's a very compact protein, and it needs special circumstances for digestion. So casein, for example, needs a special enzyme which will unravel it so that it can be cleaved in the normal digestion process. And in infants or in calves, the product that will do that is called renin. And renin curdles the milk and opens up the molecule for digestion. And so animals will produce this either in the lining of the gut. You will find pigs producing this, and calves produce it, and you can use this renin as well as an extract in the cheese production because it will help to curdle the milk. So casein is pretty species specific. The amino acid composition in different species is different. But of all mammals, human milk has the lowest protein content and the lowest ratio of casein to whey. So if we're going to compare them, for example, you will find that in the human there are 1.2 milligrams per liter of casein. That's what there is. And the time required to double the birth weight is 120 days. If you go to the horse, you'll see the horse has exactly double the amount of casein, or protein in general, 2.4 milligrams per liter, and the time to double weight is 60 days. That means exactly half. So there's a very good correlation there. A cow has 3.3 milligrams per liter, and the time to doubling birth weight is 47 days. A goat, 4.1, 19 days. A dog, 7.1 milligrams, 8 days. A cat, 9.5, 7 days. A rat, 11.8, 4.5 days. So if protein is the reason why we drink milk, then the best milk to drink is rat milk. No doubt about it. There's another problem that we have over here. We'll see that the human takes the longest to double the birth weight. Now, when a human is born, the moment the baby is born, he gets up and he walks around and says, "Where's the food?" Right? No, he doesn't do that. What does he do? He's totally helpless. And the brain is still developing. In fact, there are sutures which help it to be born, and the brain is the important structure that still has to develop. The nerves are still connecting up, and so a baby is totally incoordinate, and the nervous system has to develop after birth in a human. A human is a species where the brain is paramount. A cow is not too interested in school and calculus. It's more interested in walking around and feeding. Is that correct? And so, the food type that is geared for a cow is one to make musculoskeletal development possible and is not geared for brain development. So, if we feed the human cow's milk, then what we can do is we can induce fairly rapid growth, but it is musculoskeletal growth, and so the baby can get very, very large very quickly, and smaller infants are frowned upon that grow slightly slower. On the other hand, what is it that you would really want to develop properly, the brain or the musculoskeletal development? Well, it depends whether you're a child of a world boxing champion or of a, history professor or something like that, probably. But that's not the point. The point I'm making is that human milk, which has the lowest ratio of casein to whey, is geared for brain development. What does the brain consist of? High levels of proteins, or does the brain consist largely of fat? Basically, our brain is fatty tissue, and there are lots of fatty components. Around each of the nerve fibers, you have myelin sheaths, which are particular fat molecules. So brain and brain-connecting tissues or nerve tissues are largely fatty tissues, and so you need that type of development. Children that are raised on cow milk have a lower IQ on average than children that are raised on mother's milk. That's just a fact. So the protein that we find in this food is geared for the species, and if you work with animals in the zoo, you will know that you cannot just feed any milk to any animal. Normally they would die. The human is just so resilient that it can cope with just about any milk out there, and that's why we believe that cow's milk might be good for infants. In fact, the opposite is true. We should strive to use food that meet the nutrient needs of the older infant, yet avoid toxicity. Cow's milk simply does not meet the standard of quality. Journal of Pediatric Gastroenterology and Nutrition. So there are other problems with milk as well in terms of its purity. Here's the journal Pediatrics. You don't get better journals than these in terms of children. Babies who are fed whole cow's milk during the second 6 months of life may experience a 30% increase in intestinal blood loss and a significant loss of iron in their stools. Now, why should the infant bleed internally if it gets cow's milk? The answer again lies in the protein. The casein that occurs in the cow's milk is very hard to digest, which would mean that the situation inside the gut is such that it is more acidic than normal and very irritating to the intestine, so that these young intestines actually bleed in the process and you lose iron that way. And adults have the same problem. People who have ulcers, for example, should never ever have any dairy product in their systems because of the irritating nature of the digestive process involved. Adults who consume large quantities of milk, who have high lactase activity, suffer repeated small galactose challenges, accumulation of galactocol in the lens, and a greater likelihood of developing senile cataracts. Postgraduate medicine. Okay, what does that mean now? So the first problem about dairy products is the type of protein. The protein, casein, is very hard to digest. You need very special enzymes in order to do it. And mother's milk has human casein, and the baby would find that hard to digest. But the mother has nodes in the breast where bacteria are raised, which are called Bacillus bifidus, and this bacterium is injected together with the milk and helps to digest the casein. And then the infants also have small amounts of renin. In a cow, on the other hand, the calf produces large amounts of renin to cope with this huge influx of casein. So that's the way we deal with casein. Once a mammal in general is weaned, then it stops producing renin, and it cannot digest casein adequately anymore. In fact, once an animal is weaned, it should never, ever, ever get milk again, and there is not a mammal in the world that will naturally drink milk after it is weaned. Not a mammal in the world, except the human being. And all of us switch off the enzymes which enable us to digest the casein adequately once we are weaned. So none of us have this. But here's another problem.